everyone, welcome back to my channel. This is Shravya from Sri Venkateswara College of Engineering from CSC department. In this video, I am going to discuss about the subject mathematics. In that, my topic is vector line integration. Let us see about that vector line integration. In that, first of all, introduction to vector line integration. It is vector line integration is a mathematical concept used to evaluate the integral of a vector field above a curve. It allows us to calculate the work done by a force field along a given path. And the vector line integration is an essential tool in physics and engineering for solving problems involving line integrals. We can see some example of vector line integration in this picture. That is, if f is conservative, use the fundamental theorem of line integrals. Then evaluate using the definition of a line integral of a vector field. When coming to understanding line integrals, a line integral represents the sum of the scalar products of a vector field and the tangent vector to the curve. And it is measured the contribution of the vector field along each point of the curve. Line integrals can be evaluated in two ways, that is using parametric equations or using a differential form. You can see the line integrals that we start with two atypical examples where integrand is a scalar field integral. We write that a scalar. When come to parametric equations of line integrals, parametric equations represents the curve as a vector function of a single variable. And to evaluate a line integral using parametric equations, we substitute the parametric equation into the vector field and compute the integral. Then the result is a scalar value representing the total contribution of the vector field along the curve. When come to differential form of line integrals, first fundamental theorem is, first step is derivative of an integral. Derivative matches upper limit of integration. Lower limit of integration is a constant. In that, a differential form represents the curve has differential equation involving partial derivatives. And to evaluate a line integral using a differential form, we express the vector field as a differential form and integrate it or other the curve. This method allows for more flexibility in dealing with complex curves and vector fields. And when come to the properties of vector line integration, we have vector line integration is path dependent and the meaning, the result can vary depending on the chosen curve. If two curves have the same endpoints, then the line integral along them may differ. And the line integral is independent of the parameterization chosen for a given curve. And the calculation techniques for line integrals are, we have the basic properties of integrals. Through this section, we assume that all functions are continuous on a closed interval, that is a comma b, below r is a real number and f and g are functions. In this technique, such as the fundamental theorem of line integrals or Green's theorem can be used to simplify line integral calculations. And the fundamental theorem of line integrals relates a line integral to an antiderivative of the vector field. And the Green's theorem allows us to compute a line integral by evaluating a double integral over an enclosed region. When come to the applications of vector line integrals, we have the ordinary integration of vectors. That is, the ordinary means definite or indefinite. Integral of a vector is done by integrating each orthogonal component separately. If there is a vector v is equals to v of t, where t is a scalar variable, then we define the vector integration as. Vector line integration is used in physics to calculate work done by a force field along a path. It is also used in electromagnetism to calculate the circulation of a magnetic field around a closed loop. In fluid dynamics, vector line integration helps determine the flow rate of a fluid along a curve. When come to the limitations and challenges, vector line integration can be challenging for complex curves or vector fields that lack symmetry. Calculating line integrals analytically may not always be possible, requiring numerical methods or approximations. Some vector fields may have non-zero line integrals along closed curves, indicating the presence of circulation or potential barriers. When come to line vector line integration in practice. Software tools like MATLAB and Mathematica provide built-in functions for computing line integrals. These tools simplify the process by automatically handling the numerical calculations and allowing for visualization. Vector line integration is widely used in various fields such as physics, engineering, and computer graphics. You can see the picture in this image. I'm going to conclude this topic of vector line integration. In that, vector line integration is a powerful mathematical tool for evaluating the contribution of a vector field along a curve. It allows us to calculate work done, circulation, and flow rates in various physical and engineering applications. Understanding the principles, techniques, and applications of vector line integration is essential for solving real-world problems. You can see in this image, if C is the line segment from 0 to 3, 1, 2, 3, then we have to find the remainder. Thank you.